Okay, well, thank you, Ben. Again, my name is Blair Randall. I'm a senior sales engineer for PILS Automation Safety. I'm based in California. We're going to talk about our SLS system today, which is used for lockout and tagout. But before we do that, we want to define what lockout tagout is. And as OSHA defines it, lockout tagout has two features to it. One, it is used to have prevention of unexpected startup of the equipment by having power reapplied without being controlled. And then secondly, it also is used to remove hazardous energy from a zone that it normally is being applied to when there's people in that zone doing service work. So those are the two main characteristics of lockout as OSHA defines it. There are the regulations for OSHA. They're all with, the regulations for lockout are all with OSHA. OSHA defines lockout as 1910.147 for the unexpected startup of equipment, and 1910.333 for electrical servicing, which sets forth basic requirements for employers to keep employees safe. The American National Standards Institute, ANSI, approves U.S. consensus standards to meet the OSHA regulations, and UL and others also create consensus standards in their field of expertise. As far as the standards themselves, the lockout procedural standards are under NFPA 70E for working on servicing of electrical equipment, and the ANSI Z244.1 for the prevention of unexpected startup. As far as equipment standards for lockout, UL 508 for manual disconnects using circuit breakers or mechanical switches, UL 609.47 for manual disconnects using circuit breakers or mechanical switches for which is harmonized with the IC standard, but with additional US requirements. And what we're going to talk about today primarily is the ANSI UL 6420 system isolation equipment rated as a unit. So OSHA is the Occupational Safety and Health Administration. It's part of the U.S. Department of Labor, and it has the legal authority to enforce compliance. OSHA defines several sources of hazardous energy, and you can see them listed here, quite a number of them. We're going to be focusing today on the electrical source of hazardous energy and how to deal with that. The UL standard 6420 is specifically focused on system isolation of electrical energy rated as a unit. And in 2015, OSHA accepted UL 6420 into its nationally recognized testing lab, NERDL, if you will, program. And also all OSHA 1910.147 is being rewritten, and it is expected to include the use of system isolation equipment rated as a unit. So that's in the process. Some of the elements of UL 6420, first of all, equipment is used for system isolation and rated as a single unit with all components of the system from the same manufacturer and installed and commissioned per the manufacturer's guidelines. The standard applies to isolating equipment incorporating electromechanical contactors, remotely controlled and monitored to prevent or provide remote isolation, status indication, and with defined integrity levels, referring to safety levels. This standard applies to circuits with 1,000 volts AC or 1,500 volts DC ratings or less. The system isolation equipment is expected to be used as a means of removal of power for prevention of unexpected startup of a stopped machine, and as an isolator to provide protection from electrical shock and by ensuring the removal of electrical energy. The equipment is intended for installation in accordance with the NEC standards, NEC codes, and the electrical standards for industrial machinery, the NFPA code 79. The system isolation equipment is principally intended for industrial machine applications where isolation of power is so frequently required that mechanical life of a typical disconnect means is unacceptably short, or where there are many entry points on the machine where disconnection is required, or both. Multiple entry points are a function of the access needs and the layout of the machine itself. Here are some of the challenges of traditional LOTO, or lockout, I should say, using a disconnect and locking it out. First of all, in the upper left corner, you see a picture of a disconnect panel with the disconnect locked to the off position, and we've got a clear plexiglass front to that. But if you notice, 2 of the 3 phases are actually still engaged. So even when this is locked out, there is a possibility that you're not really locked out. You actually have 2 of the 3 phases in this photograph showing power still being applied and available for, and obviously being dangerous to somebody in the zone that this is being sent to. So also with that, disconnects can fail to an unsafe position. The operator is required to stand in front of or on the side of the door to throw the lever, putting them in harm's way if there is a fault. And then, as I mentioned, visual windows are available, but that doesn't guarantee that the operator will actually see that all 3 phases have been disconnected, because you have human error in the mix. And then replacing the switch is an inherently dangerous task, often needed every 2 to 3 years in frequent use applications. And you need at least 36 inches of clearance in front of the disconnect enclosure as part of the requirements for this type of traditional lockout procedure. The other issue with traditional lockout is dealing with arc flash. The mechanic or the technician will have to don personal protective equipment specifically used for arc flash when he's actually testing that there's 0 voltage within the panel that he's locking out, or she. The tech would measure voltage is present with, by checking the meter that it's working, turn off the disconnect and apply a personal lock. Measure voltage is absent on the load side of the disconnect. Check meter again on the line side of the disconnect to ensure that it is working. And if all that shows 0 voltage in the system, then the work can be performed on the dead equipment. And that may be the dead equipment that actually is just the panel itself going inside there and doing work, or the zone that the panel is providing power to. If you've done a lockout procedure and you're locked out and you've measured voltage and there's no voltage available. All that procedure can be alternately accomplished using the SLS system that we have within the UL 6420 standard. And in 2018, the NFPA 70E standard changed to allow embedded voltage checks by devices designed specifically for that purpose. So all of this procedural stuff here with traditional lockout can be replaced by pretty much an automatic procedure within the SLS design. If you are considering using the 6420 standard for lockout, and of course that includes the use of contactors, you need to look at the specific specifications of contactors you might have in mind, and that's the IEC standard contactors we're talking about here. So for instance, this IEC rated contactor evaluates contactors for short circuit current rating, but it allows a contactor to be tack welded closed, which is not acceptable for LOTO or lockout. Normal contactor endurance testing requires 6 times the rated current on the disconnect, on a disconnect or on a contactor, which also is not acceptable for lockout. In common cause failure, at the point of a fault current, one phase is higher than the rest and will have the highest fault current at that instant. So for instance, putting 5 contactors in series will weld all in the same phase, and that is also not acceptable for lockout. So the UL 64 standard is defined as follows. First of all, the UL 64 standard is the only one to test a contactor to the same requirements as a manual disconnect to prove the isolation function. All components and the system are subjected to 6420 testing for enclosure integrity, EMC, temperature rise, safety, functionality, and durability, and tested as a unit. All power sections are tested at high power test labs and UL witness for SCCR rating as a unit and rated type 2 contacts, and the contacts cannot be welded as previously where they can on the IEC standard. Contactors go through UL witness make-break testing beyond the IEC standard for a contactor, same testing as a disconnect, and as such, the system is rated AC23A like a disconnect. And with the AC23A rating, that requires 10 times the rated current versus 6 times the rated current on a general purpose IEC rated or standard contactor. And so these are some of the issues associated with upgrades of a contactor to make sure that it meets the 6420 standard, the AC23A rating. So what are some of the limitations here? Well, for instance, if you are using a disconnect as your source of lockout, a disconnect has roughly 20,000 rated operations maximum. And for each lockout that you use, that's 2 operations, an off state and a back on state. So over 20 years, you're averaging 1.3 cycles per day if you're going to use this for lockout. And that's not very much. So depending on the actual application and use, the mission life could be significantly reduced with the use of multiple lockout procedures per day, requiring replacements frequently. So there are a significant amount of applications where lockout, tagout may be required multiple times per day, may have significant complexity, and may require several entry points of access. These photographs on the left here, for instance, here's a ride at an amusement park or a theme park where you have people coming on and off the ride multiple times per day. You have maintenance techs needing to do things to make sure the ride is functional and safe during the day by going in and either replacing parts or fixing items on a regular basis. So that's what we would call a high frequency lockout application. The photographs on the lower left here are applications where you have a fairly large scale automation process going on here. Maybe it's a packaging machine or something that causes a lot of different things to happen within that machine. And you have a lot of entry points in these machines that you want to ideally have lockout capability at each entry point. And that might be on a process application too. Here's a lot of conveyors in a process application where you have the possibility of a lot of different lockout locations that would be ideal, and the possibility of multiple energy sources that are within that cell. So you want to be able to control all that easier with a better solution than just using a disconnect. So the solution is the PILS SLS safety lockout system, again, which is UL 6420 rated as a unit. The SLS system is approved under the 6420 as a lockout device and includes many enhancements over traditional lockout methods and eliminates many of the challenges associated with traditional lockout. Besides meeting all the criteria of the UL 6420, it also adds functionality under 6420 4.8.1 for meeting additional machine control interface applications, and I'll show you what that means in a little bit here. Using remote lockout stations, RLS, that are powered with 24 volts, lockout is invoked without all of the dangerous issues associated with traditional lockout. For instance, here's 4 lockout stations that can be anywhere in the machine, controlling one source of energy. Here's the basic panel configuration. It has various functionality built inside. For instance, you have the field terminations, which is self-explanatory. We have a safety controller, which is in this particular photograph, a multi-configurable safety relay. And you have the three-phase safety rated voltage monitor down here. Remember earlier we talked about this replacing the manual means of testing for zero voltage at the source. So that three-phase rated safety monitor replaces the need to have a tech put on arc flash PPE, turning a disconnect off, and testing for zero voltage. It's all done automatically within this three-phase rated safety rated voltage monitor. You have your power contactors, which are AC23A rated, and you have a disconnect switch up here, which is disconnecting power to the panel. It is not used for lockout. This whole panel is a lockout device. The remote stations have 24 volts DC power coming in. And so basically, all you do is obviously turn the switch to the lockout state and lock it and wait for the green light to come on. Now, the green light is going to come on, but it's not going to come on immediately because there might be other things going on within the machine or the cell that have to dissipate other kinds of energy within the cell that are initiated by electrical power, which you're turning off here. And that might include, for instance, pneumatic power. You may want to have a wait until you have zero pressure of air valves, and then you may want to have a wait until you make sure that any gravity that might affect the load dropping is not going to affect that load by having the assurance that you have fail-safe braking in those type of situations. So this will turn on when it's totally safe to go into the cell. This starts the process by removing power from the cell. And also this green light may come off if it uses test pulses. And so it prevents turn on when not isolated, or there are issues with a 24 volt supply, for instance, where the system will shut down. And so that's the remote lockout station. Block diagram looks like this. Again, you have the main power switching panel over here with 483 phase typically coming into it, and then an isolated 483 phase going out of it for load power. You have some safety rated control components coming into the controller here, the configurable safety relay or a safety PLC. You have the option of Ethernet communications. You have future references to hydraulic isolation, which is not currently available yet in the UL standard. And you have pneumatic isolation panel, which is an option also now in the UL 6420 standard. And then for each panel that we either have configurations for either 4 or 8 remote lockout stations per panel. And if you have a lot of entry points, a larger cell, you can add up to 7 marshalling stations, each of them having an additional 8 remote lockout stations per marshalling panel. So with 7 marshalling panels fully loaded, you have a total of 64 possible remote lockout stations controlling this hazardous energy panel, power through this panel right here. As a matter of fact, we have an application at a diaper manufacturer that had a few issues, and they ended up, on average, using 24 of these remote lockout stations in a typical cell. And they had 2 issues. They had, the first one is the obvious one where they were doing a lot of lockout using disconnects, and they were replacing disconnects all the time as a result because of the frequency of lockout. And they had a lot of entry points within the machines, and they would prefer ways of disconnecting or locking out at each entry point. And so the SLS proved to be an excellent solution for them. And so that's why they went from the old approach to the SLS solution. There are 3 configurations in the SLS package using configurable safety relays or safety PLCs. The first one, we've had this particular design using the multi for over 20 years now, and it's this SLS design is a UL 6420 approved design for lockout, and all multi solutions are standard and pre-programmed. The user can design and install per manuals without PIL support. And then we have a new design we're working on that is going to be superseding the original design with the multi, and that's the multi 2 SLS. And it is, as I said, in development. And it will be both CE marked for European applications or other parts of the world that accept CE, and also UL 6420 approved. And so when that gets completed, it'll be superseding the original multi-design of the SLS. And then thirdly, we have a larger system, which is our PSS 4000 safety PLC, and it has two potential uses. A lot of our customers use the PSS 4000 as a machine controller because it deals with not only safety I/O, but it also deals with standard I/O. So it actually controls the entire machine process, including the safety logic associated and the safety inputs to it and safety outputs. So if that's the case, then we can expand that application to include remote I/O PSS 4000 units within the SLS design to add lockout in the total control solution. And the other application for PSS 4000 is if you have a fairly complex requirement where you have, like I said, a lot of multiple remote station requirements, but you also have multiple sources of power within a particular cell, then the PSS 4000 might be a better way to go because of its capability and larger I/O structure within that. But all PSS 4000 solutions are custom designed for specific needs. So this is how it looks in the panel itself. On the left side is a wall mount system, and it has ratings from 60 amp to 200 amp. And then on the right, we have what we call our floor mount system, which is a larger panel. And of course, the larger the current that you're switching, the larger the components need to be. So that's why you have to go to a floor mount design. And so there are 3 panels on the right for 200 amp, 400 amp, and 600 amp. So that's how it's configured in the final design as an integrated solution. So in summary, here's the benefits of the SLS system compared to traditional lockout. It provides significantly enhanced safety using dual channel contactors, safety controllers, safety rated voltage monitors, and safe low voltage control devices, 24 volts DC remote lockout stations. It eliminates the need to use 36-inch clearances required for a traditional lockout because the use of 24 volts DC is the control power, which is low enough to not be harmful. It eliminates the need to use arc flash equipment when testing for zero voltage because there's potential for arc flash when you're using traditional lockout procedures using a disconnect. It adds flexible and safe solutions for complex equipment needing multiple lockout entry points. It increases the life of the system to 1 million+ cycles compared to only 10,000 cycles when you're using traditional disconnects as a lockout device. And the power isolation is control reliable using dual channel circuitry and it removes electrical power and pneumatic power where needed. And it removes the operator from hazards associated with washdown environments by removing the presence of 483 phase at the access point. And it has the options for dealing with pneumatic pressure monitoring. And this is the add-on control cabinet for pneumatic monitoring. Currently, the SLS system addresses pneumatic power and offers options with plug-in pneumatic switch panel with inlet pressure switch and dial, calibrated zero pressure, factory tested verification switches provided for isolation to the ISO 13849-1 standard, category 4, performance level E. These are the various agencies around the world recognize the SLS system, the safety lockout system, as a approved lockout device. And if you can see, there's a lot of different agencies that accept this. We talked today about the UL 6420, which is isolation equipment rated as a unit for both unexpected startup and power isolation for electrical servicing. The NEC code has a rating for it. The National Fire Protection Agency has a rating for it. ANSI has ratings for it also. And then there's international standards, the IEC standard, the ISO standard, and then a couple of European Union standards, the EN standards, which is an IEC standard and European Union standard, and a couple of Canadian standards, the CSA standards on the bottom. So there's a lot of acceptance around the world using this system as a solution for all of the negative things that traditional LOTO provides. This provides the solutions using all of these standards. So OSHA already allows SLS to be used as an operator task or minor servicing device for prevention of unexpected startup. And there are two options for grade changes: major servicing and electrical servicing, until OSHA selects a certified and authorized nationally recognized testing lab to actually test the 6420, and that hasn't happened yet, but it's in the process. But in the meantime, there's two options. One, a risk assessment can be performed that details why the SLS is required for lockout versus traditional LOTO. The risk assessment then needs to be part of a request to OSHA for a variance of acceptance for a specific application. And then option two, OSHA automatically accepts the installation of a jurisdiction having authority, JHA. JHA can be a state, municipal, or local agencies that having authority at the plant location for electrical building code. And so those are the options for having OSHA sign off on using the SLS as a lockout device currently. And then they'll be upgraded once this newer solution is completed with OSHA, which won't take too much more time, hopefully. So over the last 20 years, we have sold and helped start up many SLS systems. And when we got approval with the UL 6420 standard, we have also sold and helped start up over 500 SLS systems. So we have a very good track record with this solution. We've done it for many years. And then, as a matter of fact, there has never been a case where OSHA citations have been issued to any of these accounts using the SLS as a lockout device. So it's a great track record. So we appreciate your time today, and we look forward to any applications we can help you with using our SLS approach for lockout tagout. And with that, I'll turn it back to Ben.